Let's go. Yo, why aren't you getting ready for the big party tonight, dude?
Man, I can't go. I got a final tomorrow in SBU 22. If I don't pass this, I'm not going to graduate. I need to know a bunch of these astronomers like the back of my hand.
Dude, what astronomers do you need to know?
Aristotle, Parkhurst, Copernicus, Kepler, Galileo, Newton, and Einstein.
Wow, dude, that's a lot. I don't know anything about them, but I'll be out at the party, dude. Hit me up if you need anything. Good luck, okay? You'll be fine, dude.
Alright, have fun.
Peace, yeah. I'll see you.
Jeff, wake up.
Who are you?
How'd you get in here? I'm Christian Doppler, the physicist who founded the Doppler effect.
Alright, well, what's the Doppler effect?
Doppler effect? It's the change in frequency of a wave for an observer who's moving relative to the source of the wave.
Alright, well, can you say that again? Slow down and in English, please.
Come grab a seat. I'll explain it to you.
Alright.
Think about when a police car is approaching you. The sound of its siren has a higher pitch than when it's past you and moving away. When the car is approaching you, the sound waves from the siren, they're closer together, so they have a higher frequency and a higher pitch. But once the car is moving away from you, the sound waves are more spread apart, so they have a lower frequency.
And a lower pitch.
Exactly.
Well, why does any of that matter for astronomy?
Well, if we apply that same principle to electromagnetic waves, we can measure how fast stars and galaxies are moving towards us or away from us. So ultimately we can measure how fast the universe is expanding. But you would know all this if you were studying and not falling asleep.
Well, the thing is, that book is really boring. I can't study by myself. I just get too bored and lose interest. I'm the type of person that needs to be studying with other people or be more active, you know?
I think I can help you out with that. Let's take a quick walk and I'll introduce you to some of my friends.
Where are you taking me?
Hold on, we're almost there.
This is crazy.
Here we are.
Who's in there?
An old friend of mine. I think I'll be able to help you out with some of your studying problems.
Alright, that sounds great to me. Whoa, where are we right now?
We're in Athens, Greece.
And who's that guy that's over?
That's Aristotle. Please tell me you've heard of him.
Yeah, I have, but didn't he die like 2,000 years ago?
Well, it's 325 BC, so still has a few years left to live.
Wait, so did we like travel back in time?
Save your questions for Aristotle. Come on, let's go talk to him.
Christian, so nice to see you. What brings you back?
Aristotle, it's nice to see you. I brought my student Jeff with me.
How you doing, Jeff?
Good. He was wondering if you could tell him a little bit about your work in astronomy.
Of course. I've been pondering the heavens for a while now. I find them quite fascinating. And from the way that I see it, the universe is made up of 55 concentric crystalline spheres to which all planets and stars are attached. Now these spheres move around the Earth at a constant angular velocity, so all the planets move with them.
But what makes the spheres move?
Well, this is a little more complicated than I wanted to get into, but beyond the spheres of the stars, the outermost sphere is in the area that I like to call the prime mover. Now the prime mover rotates the outermost sphere, which in turn causes the spheres below it to rotate as well.
That sounds pretty complicated. Wouldn't a comet just crash into one of these spheres and just shatter it?
Okay, Jeff, that's enough questions. Thank you, Aristotle. That was really helpful. I'm going to take Jeff and have him meet some of my other friends, but hopefully we'll see you again soon.
Alright, good meeting you.
Nice meeting you, Jeff.
Thank you.
See you soon, Doppler.
Absolutely.
Well, that was certainly interesting.
I know it seems like crazy talk now, but at the time Aristotle's ideas were widely accepted. But hold on here, let's move on to my next friend. Jeez.
Whoa, where are we now?
Now we're in Turkey. It's 120 BC, and there's my friend now, actually, Hipparchus.
Hey, Christian, what's up?
How's everything?
This is
My
Jeff.
student Jeff, the one I was telling you about.
Yeah. Christian was telling me about your test you need to take, so I'll be glad to help you with anything you need to know.
Okay, well, what did you do, Mr. Hipparchus?
Well, I did a lot of things, but most often, attributed to developing trigonometry.
Well, that doesn't really help me. I need to learn about astronomy.
Well, you see, it's all connected. My, understanding of trigonometry allowed me to study and learn about the motion of the sun and solar eclipses. And with my study of the stars over many, many years, I was able to accurately predict solar eclipses and the motion of the sun. And if I was your professor, I would test you on my motion of the sun model.
Well, then what did you discover from all that?
Well, for the longest time before me, astronomers knew that the lengths of the seasons weren't equal, but they had no calculations to back it up. What I did was make simple observations of the solstice and the equinox to, have calculations.
Wait, what are the equinox and solstice?
Well, during the equinox, which happens twice a year, the center of the sun is on the same plane as Earth's equator. And during the solstice, which also happens twice a year, the sun is in the highest point of the sky between the North and the South Pole.
Oh, that sounds pretty odd.
Yeah, so this means the sun doesn't move around Earth in a perfect circle at a uniform speed. And this must mean Earth is offset from the center of the sun's orbit.
Wait, I thought all the planets revolve around the sun.
Are you crazy?
I mean, I'm pretty sure. I think I'm...
Just be quiet and listen.
Anyway, I made a new discovery about the motion of the moon. People used to think that the moon only had one orbit, but I would sometimes observe that the moon would move in reverse relative to Earth. So I concluded that this must mean the moon has another orbit, which I call an epicycle, on top of its main orbit, the different.
Alright, so I see what you're saying. The moon revolves around the Earth, and then on its own, second orbit on its own.
That's right, Jeff.
Well, we should get going now. We have a few more people to see, but thank you for your time.
Yeah, anytime.
Thank you for sharing your ideas.
Absolutely. Good luck.
Okay, man. Well, that was pretty insightful.
I'd say it's all pretty insightful when you didn't know it beforehand.
Oh, now, alright. I was gonna learn it eventually.
What, through osmosis by sleeping on your book?
Maybe.
Come on, let's meet my next friend.
Oh.
Relax, Nicholas. We're not here to report you to the Vatican.
Christian, you can't come barging on me like that. You nearly scared me to death.
My apologies, old friend.
Good to see you.
This is my student Jeff. He is or should be very interested in your work.
Nice to meet you.
Great to meet you. So as you know, Jeff, it's the year 1535, and this is the brilliant Nicholas Copernicus.
Oh, I've actually heard of him before. You must be a pretty smart guy. So you think you can share with me some of your findings, maybe your take on the model of the universe?
Well, Jeff, as a practicing and devout Christian, I would never question the structure of the universe as laid out in the Holy Book. However, I have been experimenting with this new model that I believe explains the apparent retrograde motion of planets and their alignment. It's really quite fascinating to me, as you can see.
Whoa, slow down. You're going too fast here. What is retrograde motion?
My apologies, Jeff. Retrograde motion is the forward and backwards motion of planets in our night sky. You see, the models of Aristotle, Hipparchus, Ptolemy, they cannot explain this, but mine can. See, it's all laid out here in my book, De Revolutionibus Orbium Coelestium.
I don't have time to read that whole book. I test this tomorrow. Can you please just explain it to me, like, on the board?
Very well. The model that I propose is not the typical geocentric model, but rather it's a heliocentric model. As you can see here, the Sun is at the center of the universe, with the planets surrounding it, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, and on the outer edge, the fixed stars.
The church didn't like that too much, did they?
Yeah. Anyway, the placement of the planets in this order corresponds to increasing period lengths, which makes sense. Also, these increasing period lengths can help explain retrograde motion, as each planet moves around the Sun at different speeds.
Well, that's pretty neat. That's fascinating stuff, but aren't you missing some planets? I know Pluto used to be one, but then wasn't one for a while. But forget that, there's got to be at least some other planets we're missing.
What's Pluto? I've never heard
Well,
of it.
it's time to get going now, Jeff. Nicholas, thank you for your help. Sorry for our haste, but we have a few more people to see, so.
Absolutely. Come visit again, Doppler.
Absolutely.
Good luck on your test, Jeff.
Thank you.
Thanks.
Bye now.
Let's get at it.
Wow.
You know that? Starting to understand what all these astronomers are talking about.
Well, don't speak too fast. There's still plenty for you to learn.
Yeah, but it's just all starting to make sense to me.
Well, good. That's the point of all this, but here's the next stop.